Alright, welcome back to Mr. P Helps with Algebra 2. This is Unit 1, Topic 3, SLT14. First we're going to talk about exponential growth versus exponential decay. Growth means it's getting larger, decay means it's getting smaller. So 0, 1, 2, 3, 4 is the domains, and the ranges, it's going from 270 to 90 to 30 to 10, which means it's getting smaller. So this is actually times 1/3. Anytime you have a rate which is between 0 and 1, then you're talking about decay. So basically any proper fraction. And anytime this is multiplied by 2 times 2 times 2, so anytime it's growing, so that's growth, when the rate is greater than 1. Now keep in mind that if the rate is negative, then it's not an exponential function. So the only choices is either going to be a fraction, or it's going to be greater than 1, or it could be an improper fraction, which is greater than 1, or it could be 1 itself. So if all the numbers just stayed the same, but then it's going to be linear because it's going straight across, so it's no longer exponential. Alright, so getting into this lesson, so we're going to talk about growth versus decay. This is a growth question. I know that because the rate is 3, so it's always y equals a times b to the power of x. So review from the last video. So a is always the y-intercept, so the y-intercept is right here. So in this case, 3 to the 0th power is 1, so 1 is the y-intercept. It's usually the number that's in front, but there is no number in front here, so it's really 1 times 3 to the power of x. Then, if I was going to do f of 1, so let's say x was 1, 1 would be 3, 1, 2, 3. If I put 2 in for x, 3 squared is 9, which would be all the way up here. If I put negative 1 in there, so remember, anything to a negative exponent is the same thing as its reciprocal, which would be 1/3 in this case, so you flip it, so 3 becomes 1/3. So f of negative 1 is 1/3, f of negative 2 would be 1/9, and it's never going to get to 0, because 0 is what we call the asymptote. So it becomes 1/9, 1/27, 1/81st, so it's going to get smaller and smaller and smaller and smaller and smaller and smaller. It's going to get 3 times smaller each time, but it's never going to hit 0. You cannot cut something in half. You can cut something in half 1,000 times, but you're still cutting something. It's never going to be nothing. So this is continuous, as you can see clearly that I drew. Its domain is going infinitely in both directions, so that's all real numbers. Its range would be anything that's greater than 0, because remember, it's the asymptote is y equals 0. So if y equals 0 is the imaginary, I put a dotted line right here, so that's the line it's never going to hit. That's called the asymptote, asymptote. I believe I spelled that correctly, maybe I didn't. Alright, so let's talk about end behavior. These two questions basically, so it's going increasing this way and it's decreasing forever this way. So what is the end behavior? So as x is approaching negative infinity, meaning the left side, because negative infinity means to the left, so all the numbers that are getting smaller. So as the x, the domain, approaches negative infinity, the height is approaching 0, because it's getting closer and closer and closer and closer and closer, but it's never actually going to hit 0, so it's approaching 0. As x is getting bigger, which is to the right, the graph is going up, which means f of x, the height, is going to be increasing towards positive infinity because it's going up. Had it been going down, it would be heading towards negative infinity. Alright, so this one's going to be a decay question because 1/3 is the rate, and 1/3 means it's getting smaller each time. So once again, the y-intercept is 1. So if it was 1, so 1/3 to the first power would be 1/3. 1/3 to the second power would be 1/9. And what you're noticing is that it's the exact inverse of the question I just did. So if it was 1/3 to the negative first, I have to flip it so it actually becomes 3. So negative 1 is 3, and f of negative 2 is 9. So it's going to look exactly the opposite. So it's got an asymptote again of 0, so it's not going to hit 0. So a lot of this is very much going to be the same. Yes, it's continuous. How do I know? Because every single domain always has a range. So if I put a decimal in for the exponent, it's still going to have an answer. Everything has an answer. All real numbers do. What is the domain? So the domain would be all real numbers. I'm sorry, yes, all real numbers, left to right. The range would be everything that's above 0. So it's getting smaller as it goes to the right, and it's getting larger as it goes to the left. So let's talk about end behavior. How do the arrows behave after it passes the graph? So as you go left for infinitely, it's going to be going up infinitely. So that's positive infinity. As it's going right infinitely, it's going to get closer and closer to 0. It's approaching 0, but it's never going to hit 0. So once again, so I remember this is growth, this is decay. I know it's decay because it's a fraction. I know it's growth because it's a number greater than 1. The y-intercept, well, there is no number out front, so it's just 1. This is growth. The domain be all real numbers. It is every single time. The range will be everything that's above 0 because there's no asymptote here. So it's really like plus 0. If you ever see a plus or minus at the end, that's the asymptote. But since there isn't one, it's really just plus 0. So 0 is the asymptote. So that would be y equals 0. Range will be everything that's above it because it is a function that's going up like this. It's growth. As it's approaching to the left, it's getting closer and closer to 0. As it's approaching to the right, then it's getting closer and closer to positive infinity. Now this one's decay, which means it's getting smaller, which means each domain is half as big as the previous number. So the y-intercept is 1 again, because there's no number on the outside. This is decay. The domain is all real numbers again. The range is everything above 0, because the asymptote is, once again, there's no number here, is y equals 0. As it goes left, it's positive infinity, because as you go left, it's going up infinitely. As you go right, it's going closer and closer and closer to 0. So this would be 0, this would be positive infinity. It's kind of the inverse of this one, because this is growth and this is decay. So it makes sense that they're opposites of each other. All right, so now 3 over 2. I know you're thinking that's a fraction, so it's got to be decay. But no, it's not, because 3 over 2 is an improper fraction. That's really 1.5, which is above 1. So this is actually a growth question. It's not growing as quickly as 2 or 3 or 4 or 5, but it is growing. The y-intercept is still 1. The domain is still all real numbers. It always is. The y-intercept is, the asymptote is still 0. Y equals 0, greater than 0. And this is going to be the same as the growth. So as you go to the left, it's getting closer to 0. As you go to the right, positive infinity. All right, so 20. This is a decay question, but this is the first time we've seen this. This is not a decay question. This is a growth question. And the reason this is growth is because of this negative exponent. Now, you may remember from the laws of exponents that anytime you have a negative exponent, you must do the reciprocal. So 2/5 becomes 5 over 2 to the power of x. So that negative exponent became positive when I did the reciprocal of this number. So now this is actually a growth question. This is going up by 2.5 times 2.5 times 2.5 times 2.5 times 2.5. Still 1. Okay, a lot of the information is going to be the same. So everything else is just the same. I'm trying to get through all this. So remember, this looks like growth, but this is actually a decay question. This is really 1/6 to the power of x, because negative x, you have to flip it to the reciprocal, becomes 1/6, so that's actually a decay question. So this is going down. Each number is 1/6, or divide by 6, of the previous number. So whatever this was, divided by 6, and that's the next integer, the next, of the domains. 7 eighths, once again, you got to flip it. This is growth again, because that becomes 8/7. Now I want to get to a question that actually has an asymptote. This has an asymptote of 1. And I know it's an asymptote of 1 because there it is. This one has an asymptote of -3. So that's going to change some of these answers. This also has a y-intercept of -4. So when I graph this one, so I'm thinking this is growth, okay, but it's not because this is negative. This is really 1/2 to the power of x. So this is decay. So you're probably thinking it's going to look like this, but it doesn't. Well, first of all, it's got a y-intercept of -4. 1, 2, 3, 4. So let's say that's -4. It's got a horizontal asymptote at 1. So it's going to be up here. Okay, not a very good dotted line. And you're probably wondering, wait a second, how's the y-intercept below the dotted line? Because this has been reflected over the x-axis. And the reason why is because the y-intercept is a negative. Anytime, anytime then that's a negative, then it's going to be flipped over the x-axis. So this is actually going to look like this. So the next thing you're probably wondering was, wait a second, I thought that this was decay. Well, once you flip it over the x-axis, decay, which usually looks like this, is going to look like it's increasing. So just because it's going up doesn't make it growth. This is decay. This is exponential decay. So these numbers are getting they are getting smaller in this case. It's just because of that negative. All right, so domains. The domain would still be all real numbers. The range would be everything that's below 1, so that's y is less than 1. As the numbers are approaching to the left, the numbers are getting negative infinity. They're getting closer to negative infinity, which is down. As the numbers are getting bigger to the right, the domains, then the numbers are getting closer and closer and closer to 1, because that was the asymptote. All right, so this one, so we've got an asymptote of -3, so let's just say that's a -3. It's got a y-intercept at +2. It's 2/4, or is that 3/4? I can't really tell, so that means it's going to be decay, so it's going to look something like this. But it's never going to hit the -3 line. So its range is going to be everything that's above -3. It's decay because this is a fraction. To the left, it's positive infinity. To the right, it's going to be closer and closer and closer to -3. All right, so that gets us to the homework. So I can plot the y-intercept, which is 2. I know that. It has no asymptote over here. Well, I mean, it has an asymptote. It just has an asymptote of 0. There's no number for the asymptote. And it's 2/5, which means that it's getting smaller. So 2/5 is really 0.4. So if I plug in a number, so let's say I plug in 1 into the calculator. I know you can do this with the graphic calculator. 1 times 0.4, 0.4 to the power of 1 is still 0.4. 0.4 of 2 is 0.8. So f of 1 is 0.8. So it's going to be around right there. If I put in -1, so -1 flips 2/5 to 5/2. 5/2 is 2.5, and 2.5 times 2 is 5. F of -1, 1, 2, 3, 4, 5. Okay, so normally I would use a graphic calculator. I'd put in more points, but I don't have one on me. I'm trying to save time, so it looks kind of like this. That gives me a kind of an impression. So it's 2/5, which means it's decaying. That makes sense. The domain is all real numbers. Its range, it would be everything that is above 0. Its y-intercept was 2, as I had already mentioned before. And its horizontal asymptote is at 0 because there is no number here. So it's really, its asymptote is right there. All right, so thanks again for watching. Please give it a like to help you learn something about writing exponential equations, or functions, I should say. And subscribe if you haven't done so already. Thanks again for watching. Have a